And now in this video, we're going to cover a few examples of partial fraction decomposition. So for our first example here, we're going to do the integral of x squared plus 4 all over 3x cubed plus 4x squared minus 4x dx. All right, so we're going to look at this integral here. And now the first thing we need to notice is that the degree of the polynomial in the numerator is lower than the degree of the polynomial in the denominator. So we, in fact, do not need to do our polynomial long division first. All right, so this is just about set up. Then first we need to factor this denominator. And so we'll write that out. And to factor here, well, we can notice we can pull out an x. So we get 3x squared plus 4x minus 4. And then we need to factor this part, which factors into 3x minus 2 times x plus 2. There we go. And so once we get this factored, now we can rewrite x squared plus 4 over this 3x minus 2, x times 3x minus 2 times x plus 2. And this is equal to a over x plus b over 3x minus 2 plus c over x plus 2. Okay. And now, once we are here, what we want to do is we want to multiply through by this denominator. So let's go ahead and do that. We're going to get x squared plus 4 is equal to, once we multiply through on this right side, let's multiply on the a over x term. This becomes a times, the x's cancel, so we're left with 3x minus 2 times x plus 2. Then we have plus b times, and then the 3x minus 2 cancel, so this is x times x plus 2, plus c times x times 3x minus 2 as the x plus 2 term cancels there. Okay, once we have that done, now we need to solve for a, b, and c. So here's how we can do that. Well, we can say if x is equal to, notice if x is equal to 0, we're going to cancel out the b and the c, so we're just going to be left with a. So if x is 0, then we get 0 squared plus 4 is 4, is equal to a times 3 times 0 minus 2, so negative 2, times positive 2, plus, and then these are both 0 when we plug in x equals 0. So, in fact, this implies that a is equal to negative 1, right? 4 is equal to negative 4a, and so we get a is negative 1. Okay, well, let's keep going. If we want to solve for b here, notice that if we plug in x is equal to, right, 3x minus 2 is equal to 0, or 3x is equal to 2, so we want to plug in x is equal to 2/3 there. So if we plug in x is equal to 2/3, then, well, 2/3 squared is 4/9, plus 4 is equal to, plugging in 2/3 into this term makes it go to 0, plus b times 2/3, 2/3 plus 2. 2 is 6/3, right? So 2/3 plus that is 8/3. Plus, and then plugging in 2/3 into this term makes it go to 0. So let's see, 4 is 36/9. So we have 40/9 is equal to b times 16/9. All right, we can multiply by 9/16 on both sides. And this gives us 9's cancel, 10 over 4 or 5 over 2 is equal to b. So we get 5 halves here for b. Now, if we want to find c, then we can plug in x equal to -2 to get rid of a and b. So if x is -2, then -2 squared is 4, plus 4 is 8. So we get 8 is equal to 0 plus 0 plus c times -2 times 3 times -2 is -6 minus 2 is -8. So we get 8 is equal to 16c, or in other words, c is equal to 1/2. All right. And now we have all three of those. And so this means that our integral becomes the integral of, and now we need to rewrite out this right here, but with our a, b, and c. So what is that? Well, that's a over x, so that is -1 over x, plus b, b is 5/2 times 1 over 3x minus 2, plus c, which is 1/2 times 1 over x plus 2. And this is the integral we actually want to solve. And we can do that pretty quickly here. The antiderivative of -1 over x is -ln absolute value of x plus 5/2 times, here we have a u sub, u equal to 3x minus 2, so du is 3dx. So we're ultimately going to get, once we do the u sub here, write that out if you need, 1/3 times ln absolute value of 3x minus 2. And then we get plus 1/2 ln of x plus 2, running out of room there, sorry, plus c. Okay, so we have completed our integral. And that's essentially how these partial fraction decomposition problems run. I do want to do a few more examples. Before I do that, though, I want to look at an alternate method for finding a, b, and c. In this previous case, what we did was we plugged in specific x values to reduce down and get a, b, and c. And that works out this way, or in this case, because when we plug in -2 here, we cancel out our a and our b, so we're able to just solve for c. If that works, that's really nice. And this does work a lot. However, it doesn't work all the time. So, let's look at what else we could have done. This next method will work all the time, but it tends to be a little bit more algebraically intensive. Not too much, especially with polynomials of this size, but it does take a little bit longer than just plugging in 0, right, when that happens to work. So here's what we'll do. Notice that we got to this step over up here, x squared plus 4 is equal to a times all that stuff. So I'm going to rewrite that now. X squared plus 4 is equal to a times 3x minus 2 times x plus 2 plus bx x plus 2 plus cx 3x minus 2. Okay, once we're here, we want to combine like terms and multiply everything out. First multiply everything out. So we get a times, let's see, this is 3x squared. 3x times 2 is plus 6x minus 2x minus 4 plus b times x squared plus 2x plus c times 3x squared minus 2x. All right. So this is 3ax squared plus, this is 4x, so 4ax minus 4 plus bx squared plus 2bx plus 3cx squared minus 2cx. Okay, so we have all of that. Now, what is nice about this? Why is this useful? Well, let's combine like terms and see what happens. We have an x squared here, we have an x squared here, and we have an x squared here. So we have 3a plus b plus 3c times x squared. Okay, let's go ahead and cross those off to keep track here. And then we have, as far as x's go, we have plus 4a x's and plus a 2b minus 2cx. Okay, cool. And then we have minus 4, that was supposed to be minus 4a there, as our a got distributed to each of those. So minus 4a. Sorry, I left off that a. All right. So x squared plus 4 is equal to all of that. Well, here's what we can notice. We notice that this polynomial on the left has to equal this polynomial on the right, which means the coefficient 1 has to equal this right here. So 1 is equal to 3a plus b plus 3c. And then we have 0x. So this is going to be 0 is equal to 4a plus 2b minus 2c. And negative 4a is equal to positive 4. So we have all of those statements. Now, here we can immediately solve and get a is negative 1. Okay, well, if a is negative 1, let's go ahead and plug that in. 1 is equal to negative 3 plus b plus 3c. And 0 is equal to negative 4 plus 2b minus 2c. Okay. So we get b plus 3c is equal to negative 4, just by positive 4, just by moving that 3 over to the other side. And over here we get positive 4 is equal to 2b minus 2c. Okay. Now, with all of that, right, we just need to solve this system of linear equations. We have two equations, two variables. So I can subtract off 2 of these from this one, and 2b minus 2b is 0b. Negative 2c minus 6c is negative 8c. 4 minus 8 is negative 4. And so we get negative 8c is equal to negative 4, or in other words, c is equal to positive 1/2. All right, we've got two of them. And so to finish this out, we can just plug these back into any equation we have here. So let's see, we have b plus 3 times c, which is 1/2, is equal to 4. So b is equal to b plus 3/2 is equal to 4. So b is equal to 4 minus 3/2, which is 8/2 minus 3/2, or 5/2. So we were able to solve the problem completely in this way too. And what that was, again, was just multiply out your polynomial over here. Combine your like terms, so combine all x squareds, all linear terms, combine all constant terms. And when you do that, you're going to have a polynomial is equal to a polynomial. The polynomials for those two polynomials to equal each other, the parts have to match, as in the coefficient on the x squared on the left has to equal the coefficient on the x squared on the right. So we just write that out. Okay, and we just write all of those. This gives us a system of equations with a certain number of variables. In this case, 3 equations, 3 variables. We can solve those equations for the variables. And we did here. All right. Let's do one more example in this video, and then we'll be done. Okay. So let's solve the integral. 2x cubed plus 5x squared plus 8x plus 4 all divided by x squared plus 2x plus 2 squared dx. And now what we'd like to notice at first here is the degree of the numerator is a cube, is 3, right? It's a cubic. the degree of the denominator is? Well, we got an x squared term squared, so we're going to have an x to the fourth here. So we have degree 4 polynomial in the denominator. 3 over 4 here tells us that the degree of the numerator is less than the degree of the denominator. So we, again, do not need to do polynomial long division first. We can go straight into finding our partial fraction decomposition. So let's do that. 2x cubed plus 5x squared plus 8x plus 4 all over x squared plus 2x plus 2 quantity squared breaks up into, now what does our right-hand side look like? Well, we're going to get in the denominator, we have an x squared plus 2x plus 2, and then we're going to have a plus this thing squared in the denominator. If we have a quadratic in the denominator, that means we need a linear term up top, and again, a quadratic to a power in the denominator, so we need a linear term in the numerator. And let's, instead of doing a1 and b1 and a2, b2, let's just say ax plus b, and cx plus d. Okay, so this is going to turn into something like that. Now we need to solve for a, b, c, and d. And again, how do we do this? Well, we multiply through by x squared plus 2x plus 2, all of that squared. So let's do that. So we get 2x cubed plus 5x squared plus 8x plus 4 is equal to, if I multiply by this thing squared, then one of them is going to cancel out, and we're going to be left with ax plus b times x squared plus 2x plus 2. Plus, and now if we multiply it on this term, those things are going to cancel, and we just get cx plus d. Let's keep multiplying everything out. To simplify here, we're going to get an ax cubed plus 2ax squared plus 2ax plus bx squared plus 2bx plus 2b plus cx plus d. All right. Now we need to combine like terms. Look at all of our cubes. All right, we have 1. And that makes it ax cubed. All right, and then we need to find our x squares. All right, so I have an x squared here, x squared there. So that looks like a 2a plus 1b x squared. So we got that term, we got that term. Plus, all right, let's look at our x's. Linear terms, we got 2a there. And that's gone. We got a 2b there, so plus 2b. Plus c, oops. Plus c. Okay. And all of those times x. We got that one, and we already got that one. All right, plus 2b plus d. All right. And all of this is, of course, equal to the 2x cubed plus 5x squared plus 8x plus 4. All right. So once we have that, now everything is looks the same on each side here, which tells us we can directly say, all right, this tells us a must equal 2, right? 2 is the coefficient on x cubed, so 2 needs to be the coefficient on x cubed here. All right, and then here we have 2a plus b is equal to 5. And then here we get 2a plus 2b plus c is equal to 8. And then we have 2b plus d is equal to 4. All right, awesome. So a is 2, we got that. If a is 2, this tells us that we get 4 plus b is 5, or in other words, b is 1. If b is 1 and a is 2, this is 4 plus 2 plus c is 8, so c is 2. And then b is 1, so we get 2 plus d is 4. In other words, d is 2, which tells us this integral here is the integral of 2x plus 1. All right, we're just looking at this statement right here. A is 2, b is 1. So we get 2x plus 1 over x squared plus 2x plus 2 plus cx plus d. All right, c and d are 2, so this is 2x plus 2 over x squared plus 2x plus 2 quantity squared. All right, now we need to do the integral for these two. First, what we'd like to notice is if u here, for this integral, if u is x squared plus 2x plus 2, then du is 2x plus 2, which is exactly the numerator. So we're going to be able to do a u sub for that one. We'll come back and do that later in just a bit once we break everything else down. But we will be able to do that. Now the problem is this one right here. This is not so obvious. We could again do a u sub with x squared plus 2x plus 2 equal to u if this numerator was 2x plus 2. Unfortunately, it's not. So this may seem a little tricky, but what we're instead going to do is we want it to be plus 2, so I'm going to add a 1 in that numerator. If I add a 1 there, I of course have to subtract a 1 in that numerator. Okay, so what I did was I added 1 and I subtracted 1. Why did I do that? Because I wanted this to be 2x plus 2 in here. Now, this means we can separate our fraction, and this is 2x plus 2 over x squared plus 2x plus 2 dx minus the integral of 1 over x squared plus 2x plus 2 dx plus the integral of 2x plus 2 over x squared plus 2x plus 2 quantity squared dx. Okay, and now we need to finish out those three integrals. How do we do that? Well, again, here on the first one, we get u is equal to x squared plus 2x plus 2, so du is 2x plus 2. And so this becomes the integral of du over u, with u equal to x squared plus 2x plus 2, minus, okay, now this one, we can complete the square here. All right. So x squared plus 2x plus blank completes a square, and we still have our plus 2 over to the side. Well, what do we need to complete the square here? Well, to complete the square, we have to divide by the middle term, divide the middle term by 2, and then square that, and that's the thing that we add here. And we notice that if we add 1 there, then this is x plus 1 quantity squared. Now, of course, if we add 1, then, well, you can't just do that by itself, right? We have to subtract 1 elsewhere. If we add 1, we need to subtract 1, right? Otherwise, we would change the function if we just added 1 randomly. So we added 1 here, subtracted 1 here, and now this is x plus 1 quantity squared plus 1 here. Okay. Nice. And then over here, so this is minus the integral of 1 over x plus 1 squared plus 1. Okay, plus dx, plus the integral of, well, here again, we get u is equal to x squared plus 2x plus 2, so du is 2x plus 2. So this is the integral of du over u squared. Okay. Well, what is all of this? Well, the integral of du over u is ln absolute value of u minus, okay, this right here is arctan. The integral of that is arctan of exactly our x plus 1, right? 1 over u squared plus a squared is arctan of x over a, or actually 1 over a arctan of x over a. A is 1 here. So we get minus arctan of x plus 1 for this. Go back and review that integral related to arctan, or the derivative of arctan, if you don't remember that. And then here we get integral of du over u squared. So this is u to the negative 2. We add 1 to that, and we get minus 1 over u, and of course plus a constant c. And we need to turn all of this back into x's. So this is the natural log of the absolute value of x squared plus 2x plus 2 minus arctan of x plus 1 minus 1 over x squared plus 2x plus 2 plus the constant c. And this is our antiderivative of the original function. 2x cubed plus 5x squared plus 8x plus 4 all over x squared plus 2x plus 2 quantity squared. And that is it.